Hey everybody, how you doing? Happy Friday. It's Friday. We're starting Matlab today. Even better than that, there's a holiday on Monday. I got good vibes for this lecture. We're going to have a good one here, introduce Matlab. And not only that, I forgot that Monday was actually a holiday when I was assigning the due dates for homework 1. So it's actually going to get pushed back by a day because it's currently due on the 17th, which is the holiday, I believe, MLK. And we need it back by 1, but it's just no good to have homework due on a holiday. What kind of fun is that? I'm sure not going to look at it when you turn it on a holiday, so that will get pushed back by a day as well. Please do, try and finish up that homework sooner rather than later, because we are now going to transition over to Matlab. We will come back to Excel throughout the class. So when we either want to learn a new simulation, we'll set it up, at least the basics of it, inside of Excel, because it's nice to see how all of those numbers lay out. We'll also look at it then later on in class when we start looking at some more kind of like equation solution techniques, so solving single equations or systems of equations or something like that. It's nice to see all of that set up at least once in Excel so you can see where all the different things are going. But moving forward, we're going to do a lot with Matlab since 15 is a Matlab class. You should be able to get away with either a local installation of Matlab or the web version of Matlab. I'm not aware of any differences. I know there were some small differences in Excel between those two platforms, but they should be identical for Matlab. So let's switch over our plan for today. I'm going to give you a little tour of what the Matlab interface looks like, where the various windows are, what we're going to look at in there. And then we're going to repeat our original material all the way back from lecture 1 with an eye on how do we do that in Matlab, obviously. And then within about 5 minutes towards the end of class, we will be able to complete the entire second lecture that we had in Excel, but using like 5 lines of code in Matlab. We can do everything that we did in there. And then we'll pick it up again on Wednesday and keep working through there and learning more about the structures inside of Matlab. So let's take the tour first, and then I'll refresh your memory about where we had started in Excel when we do that. So let's switch over there. So this is what my Matlab window looks like. Yours may look a little bit different, but you should have, for the most part, the same windows that are up here. You might have 1 or 2 different ones, and I'll point those out as we go. So a couple of things to keep in mind. There's still the ribbon. We don't use the ribbon as much in Matlab as we did in Excel. There was a lot of going up to various menus in the ribbon. Naturally, when you start programming or coding, there's a little bit less of a graphical user interface and more to do with typing the actual code. So we will still use the ribbon, but not quite as much. A few things that you'll need in the ribbon, if you want to mess with the layout that we're going to go over now, you can find more options here in the layout button. We probably won't need the plots or the apps tabs in the ribbon. Will mostly stay on the home. And then when we want to create a new either a script or a live script or a function, we'll get to the differences in those in a little while. That would be either our new script or our new live script, or more generally, you can just go to the new button. It does. You can also create like folders and plots and things like that this way. Right underneath here, this is your current path. So that's sort of where you're working. If you generate any files or you need to read from any files, if you need like a data file, it needs to be in the current path. This is your current folder over here. And all the current folder window says is what's in the current path that you've got. So I've got a couple of lectures from from earlier today. Yours might just kind of show some random stuff. It depends on where your current path is pointed to. You probably have a window underneath here, right where my face is. There's a window there called Details. And all the Details one does is if you click on one of the files in your current folder, it'll give you an idea of what's in there. We don't use the Details very much, which is why I kind of put my face on there right now, because we never really need to look in there. The one in the middle, you may have two in the middle. It depends on how yours is set up. But at least one of them in the middle should be the command window. And these double arrows here, these are your command prompt. So the command prompt is where you can go if you need to execute something right away. So you don't need to write a script, you don't need to write a function or anything like that. You just want to like calculate something really quick or check a result or something like that. The command prompt is basically one line at a time. There are some ways that you can force the command prompt to behave a little bit more like a script if you want to, but typically if you need more than one line at a time, it's probably easier to just write a script rather than try to fudge your way through the command prompt to make it work. But that's also what the two sort of greater than signs mean. That's where you would start typing, right? Your text would appear over here. There's the second to last one is the workspace. Your variables will show up over here. I want to change this a little bit like that. Your variables go here. And we're going to create, obviously, a few variables today. The information that you have in your workspace for your variables may be slightly different than what I've got here. So mine show name value class. You almost certainly have name. That one is always up there. You could have value or size or class or min, max, all kinds of different things on there. It's not super critical what's on there, but if you want to change it, you can right-click on there and select the different fields that you would like to see. For the most part, we just need name and value right now. We're not going to bother too much with the rest of that. If a window ever pops out of Matlab, or you want to force it to pop out, or you want to put it back in, these little triangles in the upper right corners of each one of those panels, if you click that, there's a drop-down menu, and you can say things like pop out or dock means put it back in. I'm going to try to keep everything docked in here so that you can see it all as we need it. The other window that you might have, there might be another one underneath here. That's your history. And all the history is just everything you've typed will show up down there within reason. The actual code inside of scripts and functions doesn't show up in the history, but the act of you having called a script or a function will show up there, as will anything that you've entered at the command prompt. So for the most part, the history is only used in its relation to the command prompt. It just shows you everything that you've typed at the command prompt, along with a couple other weird things that we're not going to worry about right now. So that's your a basic tour of what you're looking at when you're looking at the Matlab interface. The types of ways that you can interface with Matlab are about 4. There's about 4 ways that you can do it, and we're only going to worry about maybe one of those right now. So the first one is the command prompt. The second one is that you can write a script. A script is just like a series of things that you could enter at the command prompt, but it's a lot easier to organize them in a script because they don't disappear after you use them. Very closely related to a script is a function. We'll get to functions later. We're going to do scripts first. But even before any of those is another one called a live script. These are the 4 ways that you can interact with Matlab. There are some GUIs that you can use, but I don't think we're going to get to any of the GUIs. We're going to start here with the live script. The live script, the word live is supposed to imply that you can have a lot more interaction with it. So we can combine things like pictures from other files and text and numbered lists and headings and that sort of, and equations and math and that sort of stuff. We can put all of that into a live script in addition to code. And so it's nice when you're first kind of figuring out how Matlab works because you can use that normal text to write notes, which is exactly what we're going to do. The only downside to the live script is it's slow. Not like terribly slow. You probably won't notice a difference until we get further into our simulation stuff. But there is more overhead on your computer when you're running a live script. And so we mostly use it for small, like one-off kind of things, like homework problems and stuff like that. But when we want to do a real simulation and let the thing run for a few minutes, we'll do that with scripts and functions. Those are sort of the bread and butter of MATLAB is scripts and functions. Live scripts are great when you want to interact with it. And then the command prompt, that's more like along the lines of almost like debugging. We don't do a ton of work directly from the command prompt because you have to enter everything one at a time and it doesn't remember where all of that is. So let's take a look at a live script and see how a live script is set up. To create a live script, we click on that new live script button, which is what we had seen up here on the top left. Your live script may show up in a different way. It should look something like this. The first thing I'm going to do is minimize the ribbon, or the tool strip that they call it, so that we can have a little bit more screen real estate, because I've got everything kind of blown up a little bit so that you can see it better. What we're looking at in the live script is this is your work over here on the left, and then there's this dividing line down the middle, and then these are your results over here. That's specifically because we have split this into the left-right view, which is this button up here at the top. This button over here that's right next to it, this is inline. So if you do the inline, what the inline represents is if you do some work, then your result will show up right underneath it. And then you can do more work, and your result will show up underneath that. Right? It's all kind of stacked on top of each other. I actually prefer the inline view when I'm working, but it doesn't lend itself very well to this sort of a lecture layout, where it's nice to be able to see the work and the results right next to each other. So I'm going to stick with the sort of left-right layout. This last one down here is to hide your code. And obviously, since I'm trying to teach you how the code works, I'm not going to use that one because it hides the code. Although it can be useful for things like, here's a little challenge for you, and I show you some functionality, and then you see if you can develop the code. But for the most part, I'm not going to hide the code because otherwise, what's the point? I need you to see the code. You can also adjust the sizes of the windows in the usual ways, where you grab the barriers in between and kind of drag. For now, I'm going to keep the workspace fairly small so that we can focus on the live script over here. When you want to work in the live script, you can toggle back and forth between code and between text. The first thing that you see on there is probably code. So what you're looking for code, the thing that is sort of a dead giveaway that I am currently writing code, is there's a line number over here, and it's outlined in this box that's sort of grayed out, right? That means that we are currently writing code. Text would show up down here in the plain white. So those are the differences between those two things. To switch back and forth between text and code, you can use the ribbon. So I'm going to add a comment here. This is my first comment. To write a comment in MATLAB in the actual code, you use the percentage sign like we saw over in Excel, and it'll naturally go green. If you want to write text, go to any line anywhere in your live script, and then up on the Live Editor menu, there's a button for text here, which says Insert Text, and its sort of paired one is Insert Code. So if I say text here and click on that, you'll notice the cursor jumps outside of the code, and now this is normal text. And you can toggle back and forth, right? So if I said, oh, actually that was supposed to be code, I can go over here to the code button and click code, and now I've got a new code environment that I can work with. And similarly, I can toggle back to text. So it just depends on what you want to do. This is normal text, and we'll use this for notes. Right, we'll use notes here, and then we'll do a little bit of coding, and then some notes afterwards. So I'm going to delete actually, we'll just leave the first comment up there. I'm going to save this so that I don't lose it. If you are on the web-based version of MATLAB, there is an autosave feature on there. I don't remember how often it autosaves, but the thing to look for if you want to know whether it has saved or not is look right next to the name of the file on this little header. What you're looking for, if there's no star, then it's saved. All your changes have saved. If there's a little star sitting next to it, a little asterisk, that means you've made some changes that aren't saved yet. So obviously you would need to save it if that's the case, if you want normal text, or sorry, normal save features like you would do in anything else. So for example, right now you can see there's a little star there because I haven't saved it. So I'm going to hit Control S. Now it's saved on my computer. So that's normal text. Let's see how we can do what we did on the very first day in Excel, but do it in Matlab. So recall from lecture 1, we wanted to plot the normal distribution. And so I'm going to switch back over to Excel, and we'll just briefly review everything that we were doing in Excel, and then bring a couple of pictures over here so that we kind of have them as a reference. Okay, so here we are in Excel, and remember the things that we were doing in Excel last time was we had the normal distribution here, and we had started off with a simpler version of it, right? We had said we're just going to set the standard deviation to 1 and the mean equal to 0. And actually, I think it might be easier if I highlight. We had said set the mean equal to 0, set the standard deviation equal to 1, and we were going to plot this normal distribution over here. When we did that, we generated some information, and we organized that information in different ways. First, we had generated what we called variables, although it wasn't really a variable in the usual sense. I had said it's kind of our way of thinking about it, right? When I have this list of data, this -3 up to +3 up here, in our mind we sort of encapsulated that list of data as x. Even though x has multiple parts to it, the -3, the -2.5, etc., in our mind we said that's all one thing, let's just call it x, so that we can make a little bit of progress there. The other thing that we had made were additional calculated columns, right? We had this f of x here, which was using, again, our normal distribution here, and we made one element of f of x for every element of x that we had. So we ended up with another set of data here. And we were careful at the time to introduce this notation that when you have a bunch of data stacked on top of each other like that, we call it a column vector. And the way that we denote the size of those is to say how many rows does it have and how many columns does it have. So they were 13 by 1. And if we had looked at sort of the total group here as a single thing, we could also call that a matrix, and we would call that a 13 by 3. They're just sort of glued together. The meaning of it is sort of up to us, right? We can put any data that we want inside of there, but we had to come up with our own meaning to something like that, as in terms of like what do the numbers mean. So let's see how we can do this exact same process here over in Matlab, and we're going to see a couple of different ways to do it. The first thing I'm going to do is take a picture of this equation and bring it with us so that we can see it over in Matlab. Okay, and now let's switch on over. And I'm going to post this in here, paste this in here, and kind of make it a little bit smaller so that we can see it. And so what do we want to do? Well, the first thing we need to do is generate those x values. There are a couple of different ways to generate those x values. We're going to look at pretty much all three of them. But the first thing is, what do we want to call all of that data? It's very difficult in Matlab to have data just kind of floating around. You know, in Excel, you could go in and just start typing numbers, and it didn't really need a name associated with it. It could just be a location in the sheet. In Matlab, pretty much everything's got to have a name. If you're going to use it for anything, it's got to have a name. So we're going to call it x, and we're going to set x equal to all of those numbers that we had before, from -3 to +3 in increments of 0.5. One way to enter that, and sort of the most basic unit in Matlab, is the array or matrix or vector. Those are all sort of subclasses of the previous one. And all of those are entered by using square brackets. So if you put an open square bracket followed by a closed square bracket, that's sort of the most basic data unit that sits inside of Matlab. It's called an array. It may only be a single number. That's an array of size 1. It could be a column vector. We've occasionally seen row vectors, or it can be a matrix, or it can be even higher orders than that. So if we want to enter that data, we can just start typing here. We can say -3, 2, 5, 2, 1, 5, 1, 5, 0, and then go up the other way. 2.5 and 3. The other thing to note is always end your lines with a semicolon. Whenever you're defining like a variable or something, you should end it with a semicolon. The reason for that is because your code will actually execute faster if you put the semicolon on there. Because if you leave the semicolon off, what you're telling Matlab is, please display the results of whatever it is that I just did. It takes time for the computer to display the results. If it's a very short statement like that, you probably won't notice it. But you will definitely notice it when we start doing the simulations. For example, we're going to do the random walk simulations probably next Wednesday. You will definitely notice the difference if you're doing 5,000 steps and you ask the computer to display all 5,000 of those steps. It takes a little while. So do end your statements with a semicolon. And let's see what happens if we execute this code. To execute the code, there are about 3 different ways to do it. Execute code. The first way is click the green Run button. The second way is to use the keyboard shortcut, which on at least a PC is F5, but I will show you how to find your keyboard shortcut in a moment. And then the third ways are, I'm just going to kind of lump a few other ways on how to run a script. Those are pretty much the only 2 that we're going to use. I'm going to put less common ways as 3, and I'm just going to leave it at that. There are other ways to run a script, those, or a function for that matter. Those are the most common ways that we have. You can do some games like, I can right click on it and say run, or run selection, or run section, or something like that. I'm pretty much not going to use those anytime soon, so I'm just going to leave those as less common ways. The green Run button is up in your ribbon. So if you go up into the Live Editor and look to the right, there is a big green Run button up here. And if you hover on it, it'll say Run all sections, and then in parentheses it should say what your keyboard shortcut is. So here, if you kind of squint at the screen, you can see that my keyboard shortcut is F5. So that's the way that I'm going to run an awful lot of my scripts, is hitting F5 on the keyboard, because it's very convenient for me. But you can always come up here and hit Run, and it will run everything in your script, which is what we want. So I'm going to go ahead and click Run here. Notice nothing showed up over here in my results pane, but I did get something to show up over here in my workspace. The workspace is an undervalued tool when it comes to figuring out what your code is doing. The trend that I see most often when students are struggling to debug their code is they try to look at it only by looking at the code, right? They don't actually look at what's being produced. They try to interpret what they think is being produced and track the error down that way. But it's much to your benefit to actually look at what is being produced, because that will then allow you to make a link between what did I think the code could do and what did the code actually do. So the workspace is where you go to look at that. And remember, the workspace is sitting over here. Oops, my pen looks a little bit big. There we go. The workspace is sitting over here. So we had created a variable x, and then we ran it, right? There was the green Run button over here, and as a result, we have now a variable x in our workspace. It also tells us the size, which is important in Matlab. We can see here that it is a 1 by 13 double. Double just means that it's a number. It stands for double precision, so for the most part, everything we're going to have is double precision. The 1 by 13, remember, is 1 row and 13 columns. So it's not quite what we want, right? Where we see this 1 by 13 that means it's one row and 13 columns, right? Which means it's kind of spread out in this way, which is, again, not quite what we were after, right? We wanted it to have one column and 13 rows, right? We wanted it spread out this way because that's what it looks like in Excel. We can verify it, and this is where the workspace comes in extremely useful. You can just look at what that data looks like by double-clicking on it. So if you double-click on it, you'll get a variable window that will just show you what that data is, or what those data are. This is as close as we'll get to Excel inside of Matlab. It's not a perfect representation of what was in Excel, because it's not meant to be. You'll notice first there's a bunch of extra space down here that I can kind of highlight. Generally, you should not be typing data in down here. Weird things will happen if you type into the cells down there that are empty. Namely, it'll fill in a bunch of zeros all over the place, and we don't usually want that. You can also edit the data directly in here. So maybe if this wasn't supposed to be 0, but maybe it was supposed to be 9999999, right? You can do that if you want to, and it will update the data for you. I strongly advise that you never go in here and edit the data inside of the variable window by going in through the workspace and opening the variable and changing it that way. Because if you do something like that, your script that you generated over here no longer represents the data that are generated into the workspace. And it can be very confusing to say, oh, I had it right here, and then you run the script again and it overwrites your changes and you kind of lose all of your changes. You don't remember what they were anymore. So I strongly suggest that you use this only as an inspection tool, and a very useful inspection tool at that. We will often want to come back in here and look and see what these things actually look like. So that was our X, but it was close to the right form, but not quite right. It was a little bit off because it's a row instead of a column. We can fix that. This is text. To rotate a vector, there's a few different things that we can do. One is you can enter it with semicolons. So as an example, we could have written something like, I'm just going to count up because it's a little bit easier, 1, semicolon 2, semicolon 3, semicolon 4, etc., etc. Right? That's one way to do it, and that will go in a row. Whereas, in a column. If you don't put the semicolons in there and you just use spaces, you get what we got there, right? You get a row vector. You can make a column vector by doing the semicolons. Usually we only do that if it's a few data points. I'd say 13 is sort of on the edge of what I feel. I'm lazy. There's no two ways about it. I'm lazy. I don't really want to hit a semicolon every time. It's faster for me to use the space bar. So there is another way that you can do it, which is enter with spaces, then transpose with an apostrophe. As an example of that, if you had something like 1, 2, 3, 4, and I wanted to, initially, if I do 1, 2, 3, 4, it'll go across. If I want 1, 2, 3, 4 going down, I can enter it like that, and then put a single quote after it. The single quote is the one that's on your keyboard next to the Enter key, or the Return key, or something like that. That's the single quote that we're using, which is an apostrophe. That does what's called transposition, or it transposes a vector. It turns a row vector into a column, or vice versa. If you've got a column and you transpose it, it'll become a row. It does the same thing with matrices, just in a slightly more complicated way. So if I want something like that, I can come back up here. Let's copy this. I don't want to lose anything that I've done. You can just edit the code if you want, but I'm going to make new code each time so that you can kind of see how it's developing. If we had that same one and I just put a single apostrophe here, I've now transposed this. So instead of X going off in a row, if I run this code, so I'm going to hit F5 on my keyboard, I can now look over at my X over in the workspace, and you can see that the shape now is 13 rows and one column, which is describing something that looks like a column vector that looks like this. So if I double click on X, I should expect that it would be a 13 by 1. And sure enough, if you do double click on it, you'll see it's now a column vector, right? Which is very similar to what we had in Excel. Don't worry about how many digits of precision are showing here. It's not important. But we do have now a column vector. Now we want to calculate F. Math in Matlab, I would say, goes a little bit more smoothly than it does in Excel. There are some values or some quantities in Matlab that just exist as their own variable. They already are there, so you don't have to create them or use some kind of weird function to do them. For example, pi. When we were over in Excel, if we wanted the value of pi, we would have to say pi and then open parenthesis and close parenthesis, just so that Excel knew, like, no, I actually want the number 3.14159, blah, 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 blah. In Matlab, you don't have to do that. Matlab is sort of built for STEM, and so values like pi that show up all over the place, you can just type as pi, and it'll work just fine. So now let's calculate F, which is our function up here, which is our normal distribution. So how do we do that in Matlab? First of all, don't worry about the f of x, right? Don't write this as f of x like that. That's not the correct syntax. We're just going to call it f. There are ways to say f of x as like a function, which of course we are going to get to, but we're going to delay it a little bit for now. And then we write the thing that we want to calculate on the other side. I'm going to give you a weird rule here, and it's going to probably take a little bit of getting used to, and it'll be a little bit annoying while we're first doing it. The easiest rule that I can suggest when you're entering math in Matlab is to use what's called an element-wise operator. And I'm going to describe that in a moment, but first let's see how to use it. An element-wise operator is a typical math, either a multiplication, a division, or an exponentiation, or raising something to a power operation, that's designed to work on vectors and matrices in the way that you probably expect it to work, which is sort of one element at a time. So for example, that first part of the f that I'm going to write there, I'm going to write 1, and then I'm going to say dot divided by. So I'm not going to say divided by, but I'm going to put a period there and say dot divided by. The sigma that we had is just 1 right now, so we're not worried about putting a value of sigma in. And then I'll say square root of 2 times pi. But I'm not just going to say 2 times pi, I'm going to say 2 dot times pi. So anytime I see a division, multiplication, or raising something to a power, just sort of work it into your mind and say, I need a dot in front of that. Most likely, you need a dot in front of that. Although there are instances where you don't. I'm going to enumerate those here in a minute. A good rule of thumb is just always put the dot in there, and things will probably work okay. So we're going to take 1 divided by the square root of pi, and then we're going to multiply it times the exponential. But I'm going to put a dot in front of the exponential. I'm going to say minus 0.5 times, but I'm noting to myself it's a times, so I'm going to put a dot in there, which can look kind of weird, right? It looks like 0.5 dot star. Matlab knows what it means, though, right? It means take the value of 0.5 and then multiply it by whatever comes after that. The thing inside the parentheses, we had started off with a simpler version of that, which was x minus 0, because we had put the mu equal to 0, and then divided by sigma, which is 1. So this whole quantity just became x. There was nothing else in there. But we did have to square it. So we'll say dot caret 2. And then, of course, I'm going to end it with a semicolon to suppress the output that's underneath here. If I go ahead and hit F5 on my keyboard, now that I've got this code on here, you'll see that F was generated over in our workspace. It's sitting right there. It is also a 13 by 1 double. The reason that it's a 13 by 1 double is because when you took, actually, don't even worry about double. The reason it's 13 by 1 is because X started as 13 by 1, and we created a variable x here that was 13 by 1, and we fed it into the function down here. When you're using these dots like this, right, a dot times and a dot square and stuff like that, you're using what I've said a few times called an element-wise operator. And those three operators are dot divided by, their dot times, and their dot caret, which is for powers. What that means when it says element-wise is, MATLAB, please go through element by element and square the 3, square the 2.5, then square the 2, square the 1.5, square the 1, right? Go through each element in there and perform this operation. If it's multiplication, then it's saying, you know, take each element in each respective location and multiply it by the value that we want. That is typically the one that you want. It's only strictly necessary for vectors and matrices. If you do have constants, so for example, this 2 times pi right here, it's optional. If you put the dot in there, it'll behave fine. But you don't strictly need a dot in there because neither one of these are vectors, right? The 2 that sits here, that's a constant. The pi is a constant. And more specifically, they're not just constants, but they're actually 1 by 1 arrays. And anytime we have a 1 by 1 array, these are called scalars. So that's the root of the issue. The element-wise operator is for any non-scalar array. That's kind of a pain in the neck to remember, right? Especially if you're not already familiar with the idea of scalars and vectors, matrices, and arrays. It's a little bit confusing to try to remember when to use that. So my advice to you is, until you're comfortable with when you need it and when you don't, always use it. So you'll always have a dot divided by, a dot times, and a dot caret. As you get more and more familiar with it and you realize, I just keep multiplying 2 scalars together, just 2 pure numbers, right? They don't have any particular size, they're always 1 by 1. You can start to back off as you become more comfortable with it, and then just use the element-wise operators where you need them. But while you're first getting started, I would say just use them everywhere, because it's safe. It will work consistently, correctly, if you use the element-wise operator everywhere. Notice there is no element-wise operator for addition and subtraction, so you don't have to worry about that. That's not important. The last thing that we did in over in Excel was to plot this. To plot things in MATLAB is pretty easy. I would say it's easier than it is in Excel. The function to plot something is plot. Not surprising. And then you say, well, what do I want to plot? First, you give it the x values, then you give it the y values. So here we had x and y. And then if you want, you don't have to go any further than that. That is enough. If you just say plot x comma y and then run your function. Oh, sorry, not x comma y, x comma f. I say that's all you have to do, and then I make an error. X is your column of data for the x values, and here f is our column of data for the corresponding y values. The plot is a little bit tiny. On your own machine, you might be able to make it a little bit bigger than that, so I'll just temporarily make it large here. But this was the very first plot that we made in Excel. That was how you did it, and that's how we can do it here. If you want to change the appearance of that plot, you have to know a few more commands that we'll cover later. The only one we're going to cover right now is color. So if you want to change the color of that line, put a comma after the y value, and you can provide what's called a line specification. So for example, if I want that line to be red, I say quote red quote. There's a single apostrophe sitting there, and the R means please make this red. The other options that you can have are K for black and B for blue. There's more than that too. There's magenta and yellow and green and cyan and all kinds of other colors. But red, black, blue, those are the most common. that we use. And also notice that it will always by default give you a scatter with straight lines connecting the data, which if you think back to what we had seen in Excel, I said that was sort of the STEM standard. MATLAB's used in STEM a lot. It knows what the standard is when you're plotting them. It's not a smooth curve, right? It just connects the points that you have by straight lines, and that's exactly what we've got here. This method of entering X data, it's kind of a pain in the neck. If you've only got a handful of data points, that's probably okay. But most of the time when we want to generate a plot, we would like more data to be on that plot rather than like 13 points, right? Because it looks kind of chunky as we're going. There are two very common ways to generate data. Common ways to generate, I would say, vectors of data. And this is useful for plotting. It's useful for a lot of things, but we're going to see it here as plotting. One way is with the colon operator. So you can give MATLAB some information about the kind of data that you would want. And that information, if you want to use a colon operator, looks like, tell me where you want me to start. So what's your start value? Then tell me, separated by a colon, the step size that you want to take, and then tell me where you want to stop, so with a stop value. So if you say start colon step size colon stop, MATLAB will generate data starting at the start value. It'll add the step to it, and then add it, and then add it, and then add it, until it gets either right to your stop value or just shy of the stop value. It may not land dead on top of the stop value, but it could. It just depends on how accurately you calculated the step size. The other way to do that is with the Linspace operator, or I should say the Linspace function. And the way Linspace works is you give it a start and a stop, and you tell it how many points you want in between there, and it'll just generate it for you. When you're doing a plot, that's usually what you want, right? You usually just want a list of data. I need it to go from here to here, and I don't really care how far it goes, or what the exact values are. And so this would look like Linspace of start value to stop value by number of steps. That's the one that we will use most often when we want to plot something, because we don't really care what the exact values are, and we're too lazy to actually do the math to figure out the step size. It's easier to just say, give me some values between here and here. By default, that gives you 100 values. So as an example, if we were to say x is equal to linspace from -3 to 3, this gives us 100 equally spaced values. That is exactly the same as saying linspace -3 to 3 with a 100 on there. This is the same thing. If we wanted to get what we had before, we could say x is equal to linspace from -3 to 3 in 13 steps. Right? That is what we had calculated previously because we just kind of wrote it out. The one in the middle or the one in the bottom, those are the most common ones that we use, especially when we want to plot something. But if I run the script right now, notice what happened to my variables over here. One of them updated correctly, or mostly correctly, right? The x that was sitting here. This now has 100 elements in it. But the f does not, right? F is still 13 by 1. The reason for that is because of how MATLAB, and it's not just MATLAB, most programming languages execute their code. The pattern in which they execute their code always follows a particular way. MATLAB executes code. First it goes right to left, and then it goes top to bottom. So what I mean by right to left and top to bottom is the first thing that it's doing, it's going to the top of your script, and then when it gets to a particular line, it's looking at this side, and it's evaluating that. This is what I mean by the right-hand side. The right-left is defined by the equal sign. Whatever's on the left-hand side over here of the equal sign, that's what I mean by right to left. So it starts on the right, and then it evaluates whatever's on the right, and it assigns it to the left. It's important to keep in mind too that the equal sign here, this is what we call an assignment. It's not an equality. This is an assignment operator. It's there to say I want a list of data that runs from -3 to +3 in 100 steps, and I want you to call that x. I want it to be referred to as the variable x. It doesn't mean that x is somehow numerically equivalent to some particular value. There's another symbol that we end up using for something like that. So first it does the right, then it does the left, and it does that one line at a time from top to bottom. So it's going all the way back up to the top of my script and running all the way down. Everything that was up there, it's rerunning from top to bottom. So I keep redefining an x here, and it's not really doing anything. I'm overwriting x every time I do it. Notice over in my workspace, there's only one value of x, right? It just got rewritten over and over and over and over. So if we want to generate 100 values of x and then evaluate f, the call to f has to come after the call to x, which is a little bit different. That might seem obvious when you're looking at code like that, but it is different from what we had in Excel. We had to write them in a particular way, but we could actually define things first and then sort of scatter them all over the place, right? Excel had a different way of figuring out how to evaluate stuff. It had its own internal pattern, and so it could afford to do like evaluate this one and then that one over here and then go up and then go down over here, right? It could go in very strange patterns. Coding languages in general follow a very fixed, rigid pattern, which is right to left and top to bottom, which is what we've got here. So similarly, if I want to repeat the plot, I'm going to have to say plot xf again. And now if I hit F5, you'll see that the second plot that we get down here is a nice smooth plot, right? It doesn't have the sort of chunkiness that this one did. It's a nice smooth plot, which is usually what we're after. And those are the basics of Matlab, which is we're going to use a lot of stuff like this for a long time. Those are the major patterns on there. It's kind of a lot to throw at you all at once, but it is also really useful. And the reason it's, well, one of the ways I'm going to illustrate to you how useful it is I'm going to do what we did in the second lecture in the remaining like 2.5 minutes of class as sort of an illustration of it can be much more convenient to code this stuff than to set it up in Excel, even though you can do both of them as you go. So the second thing that we had done in Excel was we came up with a way to take this value and replot it for different values of sigma and different values of mu. So let's see what that would look like inside of Matlab. The first thing I'm going to do is give us a new script so that I don't do the same thing over again. And I'm going to briefly summarize what we were doing. Like what would this look like as a problem statement? It would be to evaluate, let me zoom in here, the normal distribution from -3 to +3 for any mu and any sigma, right? And then plot it. That's what we were trying to do last time. So the same way that we sort of isolated a sigma and a mu in Excel, we can do that here in Matlab. So I can say something like mu is 0 and sigma is 1. Right? I can put those up at the top. I can then generate my data. So I say I'm going to want to do a plot over a certain range. So I'll say Linspace -3 to 3. I don't have to go any further than that. It'll give me 100 equally spaced values. And then I can calculate everything that I need. Remember, I'm going to use element-wise operators here because in general you should get into the habit of doing them, even though in this particular case we don't actually need all of these element-wise operators. So times the exponential of -0.5 and then times a quantity of x minus mu divided by sigma. And then we're going to take that quantity and raise it to a square power. Right? We're going to square it. And then last is we're going to plot x and f. So in 5 lines of code, technically it says 9, but it's really only 5, right? Lines 3, 4, 6, 7, and 9 are the ones doing stuff. In 5 lines of code, then we can go through and generate a nice plot like we had seen previously. But notice the plot won't change the same way that Excel would. If I change sigma to maybe instead of 1, I put it at 0.5, the plot doesn't change. Or if I change it to 10 or something like that, the plot doesn't change. In order to get MATLAB to reflect a change, you have to run the script again. So if we set that equal to 2 and hit F5, now it'll update. Or if I change mu to, say, minus 0.9 and hit F5, it'll update. So there are some ways that we're going to see later that we can kind of trigger it to auto-update as we go. Usually we don't want it to. We like it to be like this, right? So we can work on the code and then run it and see if it changed correctly or not. But this is an example of the kind of thing that we're going to set up. Typically our code will look closer to this. This kind of code that we were writing over here, we don't often have that much normal text sitting in there. Usually our scripts will look more like this, right? Where it's kind of a block of code and some stuff next to it. But the comments over here on the script I thought were important enough that it warranted using them right now, which is why we put them there. But going forward, it's going to look a little bit more like this. So I'm going to wrap it up there. It is 3:51. I'm a minute over. Please do have a great weekend. Don't forget homework 1 is going to be pushed back to Tuesday. There is a holiday on Monday, so we will have no lecture on Monday. It won't be posted or anything like that. I'll have to check with Briege. I don't know if she's going to have office hours or not. I will check with her and see what she wants to do with that. Otherwise, stay safe, stay healthy out there. Have a great weekend. Try to take some me time to de-stress. I know things are pretty stressful right now with everything going on with the pandemic and all of that. So have a good one, and we will see you back here on Wednesday. Bye, everybody.